Welcome back to the series. So we were discussing a full stack agentic system where we were particularly today we will be concentrating upon AI agent and backend orchestration. So how a backend engineering should look like, or a bare minimum stuff that a backend engineer or any full stack engineer should know in an AI agentic landscape. What are the bare minimum stuff that he need to follow in order to work with an in order to develop an AI agentic system, a full stack AI agentic system, particularly focused on backend, right? So as you see that there is this neat little diagram. So we will go through this. So particularly what folder structure that we will be concentrating upon. I would be giving this entire source code repo link in the description. You can check it out. And I've also prepared this gist. This gist majorly talks about particularly about backend engineering related to AI agenting, which we are trying to discuss in this video. And it is a living document. You can head and then star this in order to make it a bookmark so that it lives under your GitHub space. And as and when if you find any other interesting stuff, you can always free to comment upon this. I will be sharing the description for this as well. So what this provides along with this server particularly what we will be concentrating on is this source folder, right? So what this together will find out is, what you will try to get out of from this would be that a bare minimum AI agentic landscape, what are the components, what are the backend things that you should be bare minimum concentrating during your POC or an MVP stage itself. Then later, at the later point in time, if you have to evolve into a bigger backend system, at that time you have a distributed, you are ready for making it a distributed service. At least this AI agent, whether you are working with MCP or you are working with a full-blown backend service, then you will be ready to make it a distributed system. So the overall idea today, as it names, these are implementation checklist about making an AI agentic backend a stateful distributed system. This is what that we will be touching across, right? So let's get on with it. So now the overall idea here is this entire stuff, right? This entire gist is in detail. So I'll not be going in interest of time, so that you get only the bigger picture. This is the bigger picture, right? So this is like literally coded into this. So if you look at this is entirely detailed out. So that is something which you have to do as a self work. That is when you discover more, that is when you learn more. From what I will be touching across is all the known stuff, and what are the curiosity that I can drive, so that you get into the unknown factors of it. So we will evaluate from what are the known stuffs that we know already in developing a backend system and moving towards an unknown layer. And again, this will not be a code walkthrough. It will just be an example of understanding the concepts rather than implementation, right? So while you implement it, you can refer this checklist to get into the details of what it is. Again, this will not be a code walkthrough even in this gist. This will be giving you an architectural decisions. This will be why that you have to choose this, what you will get out of bare minimum. If you follow this checklist, as I told before, you will be ready for a distributed system. At least the basics, the foundations will be clear. So again, this is not an implementation. This is something a senior or a lead engineer should be knowing in order to at least start with a POC or an MVP in case of an AI agentic landscape. And as usual, if you find any other, and always system designs, this is the system design, right? So designs are perspective driven, right? Something that might have worked for me or work for some people might not work for others, might not work for other business driven situations, or it might work in a different way, or you might have too much of a details to add upon. Feel free to dump everything into the comment section. I will review them and then I will upload it. So yeah, so this is to collectively making this AI agentic landscape a better place to be at, right? So yeah, so as you know, let's touch across the very first thing, that is dependency injection and service layer. If particularly we will talk about what is dependency injection, and I need not cover what is dependency injection particularly, but how it is applied in agentic service backend. So what is that we know? What does a dependency injection or a DI or a IoC controller would containers should add up to us, right? So we know that you already know that this is already used in your API. Any APIs that you write, you make sure that either you do a CTOR injection or you use an IOC containers and you make an injection. This is something which is already known, right? Now, the pattern that we particularly are interested here is injecting it into the service layer, right? And then that service layer getting injected into the tool layer, and then that thin tool getting consumed in an AI agentic builder, right? And on top of it, that compiled graph or that builder getting inside a controller. Now everything is in air. So how do we do this? Let's go with there where comes a, if you see this service layer getting into a tool layer and tool in turn consumed by the agent, and this built agent, this compiled agent graph that is called as compiled graph getting into the controller, where we avoid totally. This is something which is very new to AI agentic landscape. So if you go with this flow, right, if you look at this is something which you knew already. You were injecting the routes, the controllers needed for it, and the dependencies of the controller. What we had was a 3-tier architecture, right? We had nice little controller, your services, and your data access layers. So this was the 3 known layers. What is getting added in between that is, you knew that there were services and then you knew that there were controllers. What is getting added is 2 more layers, that is a tool layer, a thin layer, and an agent layer. How do we do it is something which I would gonna walk you in this particular repo. Let's get to the very first one. The route, right? Where are the routes? So here, if you see this route, now we are talking about the route, right? So I had a glitch there, so I needed to come back, but in any case, let's get to the route, right? So here, the route section. In this route section, so I was about to give you the gist about what is a service, what is how these are structured, right? Again, so in the route, you see this, the first thing that comes into picture is this chat controller. How are we injecting a tool and an agent? First is agent into the controller, right? So we see that there is an expense agent graph builder, and inside this expense agent graph builder, we take in LLM. So here where the IOC comes into picture, right? So we are not, if you get into this expense agent builder, where is this particularly? You see this expense agent, this folder hierarchy is something which you can start off with. Even there will be a folder hierarchy for this, but as of now I have kept it outside. You can free to keep it in an AI layer. That will be the more apt thing to do. But in any case, right now, this is what the expense agent builder looks like. You see this expense agent builder, it takes in a decoupled LLM, and this LLM is again something which you have seen in model. If you see this model, that will be injected into this LLM, the thin layer of tools, where in turn that tools which we were talking about will be dependent on the service, the system prompt. So overall, these are called as agent dependencies. In the agent dependencies, you inject the base chat model, the structured tool, and the system prompt. What will we achieve out of this? We will at runtime, we can switch the dependencies of an LLM. We can switch a thin layer, some other tools we can use. Why would anybody want to use other set of tools? At least think about why we went for dependency injections in non-AI systems as well. We went for a primary reason that it gives you 100% mockability. And where is this mockability is used? You might have guessed it, right? It is used during testing, right? So yeah, the overall idea of having an agent separate, the graph separate, we will get to the graph, how it is built, what are the concepts of cyclic versus a linear versus a directed asynchronous kind of a graph. We will get to that, but before to that, why is that there is a builder? The builder is there so that the dependency injections, the compilation happens outside, and while I make up a builder, I inject the dependencies of this particular graph, so that at testing phase, I switch the LLM with a non-production use. What will happen is that I will save the tokens, right? I will not hit the production LLM. I might hit with a self-hosted LLM. At that time, I have saved the tokens. I am not hitting the live production region at all. Now, with tools, what happens is that if you have to just test these graph directions, these are routes, right? As in the graphs, these are cyclically connected, right? Any typical graph, a data structure graph, you think of that, right? So if I have to see how it is getting navigated, if I have to just test, if I have to unit test this particular expense agent graph builder, at that time I can mock the tools. LLM has to just use the tools, but it need not call the actual tools which hits the service, which hits the in turn the database layer, the production database layer, right? You can switch. So n number of benefits of using whatever that was there previously before to a non-AI system. That entire system, all overall advantage gets what added to your AI agentic principles as well, AI agentic workflows as well, just that you used a dependency injection, IoC container. So that is what I wanted to explain as part of agent getting injected to this controller, right? So you see this agent getting injected as a compiled graph into a chart controller. And where did that injection had? For simplicity, I have just implemented. You can delegate this entire to an IoC container that will take care, inversify, etc. Whatever the framework that you are in. Some of the matured frameworks give it out of the box. I worked extensively on .NET. .NET offers out of the box. You need not have an additional NuGet package installed just for dependency injections, right? In case of this Node.js, Inversify is yet another one. So overall, this entire service layer, you see this we are in this stage, right? We are in the controller injection stage. So the agent is getting built over here and compiled externally. We will get into why the compilation is happening externally. You might have guessed it correct. The compilation is happening externally with an on the builder, because we can just point the checkpointer to it. We can just inject the checkpointer to it. This checkpointer might be a new memory saver, which is right off the bat offered by the LangChain LangGraph libraries, or you can have your own. You can bring your own checkpointers like your TersoDB or your PostgreSQL, where you persist your chart histories, or you persist whatever that, checkpointer here particularly is used for what? For context driven engineering. So you can use that with your own checkpointers. So this is what will a DI based agentic layer will provide, a plug and play services that it was there previously for a non-AI system as well, and even now you can implement that with AI system as well. It is just a known engineering to an unknown word of AI agentic space. That's all. Then comes the tools, right? So tools, how are tools getting built? You see this tools, there is an internal method called as init tools. Let's quickly get into the tool sections. You see this init tools. What is this tools? Tools is in turn dependent upon your service. So what exactly did change? Your controller was there, your service layer was here, and then there was data access layer. If you see this graph, your service, your HTTP API request controllers were here. For a non-AI system, your services were here, your data access layers were here. What got added is this DAG graph, which I told for the builder and compilation outside, and the init tool stuff, thin tool stuff, which is again injected with the services. These services can be your scratch off services, or these services can be something which is already existing in your system, which you are trying to bring an LLM into it. That's what an advantage that it gives. Imagine this particular layer was already there, and domain service layer was already there, the data access layer already there. You decided that here in this existing stack, or in this existing microservices, in this distributed services, an LLM can be easily fit in. So then you add these two layers in between that, then you have a highly maintainable, mockable, a testable, unit tested code. So that is what a dependency injection brings in. This is something a senior engineer, lead engineer should delegate or brainstorm upon. How do you convert your non-conventional services or a 3-tier architecture into these, adding these two and making it an AI layered architectures, right? So this is what is happening in init tools. It is dependent on express services, and init tool is only is only concentrated upon how do I invoke this expense service, and this expense service can be 100% mocked. So if at all, if you ever have to test, now think, come outside this entire the nuances part of it, come out that there is a tool which is dependent upon service, and that service is swappable. What can you test? You can test your entire tool set. That's the power that AI agents tool can be tested, can be unit tested, is something of a is something of a reliable structure, right? So entire AI systems are infamous for being unreliable, are infamous for what is a word for it, for if I have to say, they get hallucinated, they are indeterministic, they are non-deterministic system. What will happen if you test the tools before to that, they trying to become a deterministic system. If you have a test suits governing these tools, right, unit test tools, just that you introduced a IoC container, this becomes testable. If tools becomes testable, you have at least to some extent made it deterministic system. And if this expense graph is testable, the rest of the deterministic system became non-deterministic system, became a deterministic system. So there are only two undeterministic quantity that are out there. One is your graph and another one is your tool and your LLM itself. But that LLM can be refined using your prompts. So overall, don't put your service logic, don't try to say this is what you have to do at this point in time. Don't try to put in all your business logic within your prompt. What you do is you use a dependency injection, you encapsulate everything that which you want to say in terms of a deterministic code as a service, and inject that service into your tools, and that tools internally will be injected into your LLM, right? It will be consumed by your LLM. That is what the power of a dependency injection and a service layer offers to you. So you can get into the details of it, read it in general, and you will understand that, okay, you have to experiment. This is kind of a lead code, right? What I am trying to say is that I will not give you an implementation. I have given you the example of it. I have given you the checklist of it. You yourself need to figure out, you need to discuss, you need to search, you need to I mean, a typical production level, if you sit at working for any, be it be hobby project, be it be an MVP project, be it be something which you are trying to do and committed to an open source, wherever you are working for an organization, wherever it is, you discuss with your peers. If not, you brainstorm yourself, you search, you do an extensive read, or nowadays you have Gemini, you discuss with it. Then it should come down to the principles of having a dependency injection, having a mockable code. At the end, I will say this, see this, a rule of thumb is that if you cannot swap your LLM provider or your database instance by changing a single line, your architecture is too coupled. And this is how the entire flow should look like, right? This is what a dependency injection is. Let's quickly get into the next layer of it, right, which is agentic graph orchestration, that is LangGraph strategy. So what is that thing that we know? We know that the real world has retries. What do you mean by that? So before to AI agents, right, we have an API endpoint. This is an API endpoint. This is a backend server. This is an API endpoint. Again, there will be a domain service, and then there will be a data layer. What will happen if you are dependent upon any other external workflow in order to get your work done in your API? What will you do? You will try to hit another API, right, and get the work done from there and bring it. A typical microservice domain-driven development here. So there, how would you do a network call? How would you do that? How would you have a repetition there? How would you try to repeat certain works, a certain n number of works? If you have ever developed a framework, there will always be retries and there will be loops in order to get this done. That is what agentic graph and DAG graph, that is this particular graphs, that directed asynchronous graphs, the cyclic loops will give you about. So you see this is based upon a Kregel style logic. If you look at what is Kregel style logic, you will understand. Let's quickly do that. If you just go here, Kregel style graph, these are a Kregel style specific education guidelines. Oh, no. In terms of, okay, in terms of, let's say, LangGraph. right? This is inspired through that. A land graph is a framework designed to build stateful multi-actor applications with large language models, inspired by Google's, this is not Kregel, this is Prejel. I have to change this. Prejel system. Okay, what is core Prejel concepts in land graph? Land graph execution model, having influenced Google's Prejel algorithm, operates through a discrete iterative supersteps, node and actors, message passing and channels, bulk synchronizations and parallel modes, cyclic graphs. So this is what important stuff is. Unlike a traditional directed asynchronous graphs, land graph supports loops which are cycles, allowing agents to reason, take action, absorb feedback and repeat until the goal is met. That's what a LLM is typically used for. Where is that implemented? You see this, we are in the right middle of it. This is where the graph starts. And this is something which, if you are already been a land graph practitioner or any other framework, need not be land graph, any other system which could implement node and edges are considered to be graph. And why do we need it as compared to A, B, C, that is a linear model, a non-linear model, or a cyclic? Why is that we need? Because it's a state machine. Any task in LLM, what will happen is, we'll start with a one set of state. It will go ahead and mutate that state. If you look at this, it will go call model, will ultimately what it will do, it will update the state. And what is the state? If you look at this state, you will get to know this is what the state is. It is writing into this state. You might have n number of other set of variables that will be called as your state variables. Ultimately, the whole workflow, this entire node is trying to mutate right into that state or read from that state. So that is how the data gets flowed into the node, and through edges it gets connected to other set of, these are the edges. You are creating an edge, you are creating a conditional edge. Conditional edge is where the loop happens. If you have to go back to the node, if you go back to the node which was already visited again, you have a conditional edge to it. Or if you always want to go back from this node to another node, have a direct edge towards it. So the overall, it is not a video about how a land graph works or how a node or an edge in case of a graph works. Basically, it's an implementation checklist for any senior. If I am able to give you this much amount of information, you will be able to cover much landscape. The overall idea here is, in order to make use of, you don't stick to a linear based of model when it comes to orchestrating your agentic graph. You make use of something of a land graph or a graph state where it has nodes and edges, where it has self groups, cyclic groups, so that it helps you out in a long run, or in case of an hallucination or something of that sort has to happen. Or if you have to altogether branch out, imagine a situation where not every workflow you would require a LLM or a reasoning capacity, right? Here one such node is over here. For generating charts, you look at this, I don't need to call back to my LLM. Once I have generated my chart data, if I send it to my shared CN component at the in the front end, what will happen is data has to be structured in certain way, and from my API layer, if I am able to structure that data and then send it directly into my as an wire that into UI layer, why do you need an LLM to interpret this data? So there are dumb nodes. You see this, there are deterministic dumb nodes, zero LLM nodes, which are called as identify nodes that don't need intelligence. Example, data formatting, cache lookup. Here is something which is also there. That is, if you see this, context engineering. In context engineering, what happens? You need to summarize the messages, right? During the summarization, messages can happen bluntly. You can just chunk out. There are two ways of summarizing it, right? One is directly, there are 100 messages, just take the last 10 and keep it in your memory. Or, that is not exactly summarizing, that is like chunking out. That chunking out can just be a simple node where it need not require an LLM. For reasoning and for summarizing, you may require it. But for something which is a dumb kind of a node, for a cache lookup or for a data formatting, what is that you're going to have? You're going to have a node which is very deterministic in nature. Don't just trying to plug in and send every data into an LLM. You will have such scenarios, right? You will have a scenarios where not everything need to be run through or agreed upon through an LLM. Not LLM has to oversee, look at everything, so that you have a high cost of your tokens. And your LLM is overutilized just for doing mundane determining set of tasks for which doesn't need an intelligence. For such stuff, again, you would need a land graph strategy or a state machine kind of a strategy where there are nodes and graphs. And if you get into human in loop concept, that in itself is an entirety concept. You can just have a look at it, and then you will figure out what I am trying to talk about, right? That is why you would need an agentic graph orchestration. Basically, it is from a linear choice to a DAG choice, a graph choice, right? So yeah, quickly wrapping this section up as well. And now getting into something called as a thin tool centric design on inference layer. As I have already touched across, if you see this, having a tool with an IOC container makes it unit testable. And moreover, what you can do is you can inject your services. So your existing service which was there as part of this service, right? Your accounting service was there. Now this accounting service can be wrapped up as tools, and make sure that in this tool you use this Zod validator or any custom validators. This is what the capacity of tool comes into picture. And what else have to offer? Your entire service, then your multiple domain service will become a tool set to your graph, to your AI agent. That's where a thin layer of tool. Don't have, what I'm trying to say is, don't have this business logic. Okay, I'm starting with an AI agent stuff. Let me write all my domain services into a .md file, into a text file, and then feed that in terms of context engineering into your AI. No, that is not how it works. Let your domain services be as is, rather build upon your domain services, keep them as is. They are deterministic in nature. You have unit tested them, you have integration tested them, they are battle tested. This microservice was an existing let's say that it was an existing microservices back there, so it had a service layer. That service is battle tested, right? I mean, it has went through many of iteration to become what we call a stable service layer. So now that service layer, you need not just that you are bringing in an AI service, you need not strip away that service. What you do is you encapsulate that into an init tools service, and then Ola, in no time, you will be having what? You will be having a tool set that can be consumed by your LLM. So that is what I wanted to say as part of this init tools. Let me quickly see what else it is. The service injected tools. Yeah, it's a thin wrapper. It need to be a thin wrapper. You see this, all that it has to do is, what is that the LLM need to generate in order to invoke this tool. That's all. And it is Zod validated. It can be nested as well, this hierarchy, right? And it within no time gets into an expense layer. It is doing a logging and returning the success message if there is need to be, since all LLM understands in an JSON format, and not in a JSON format, in a stringified format. It will do that conversion for us, right? So it will rather do a stringify, and it need to generate. So it need to take care of its input and output. What comes in between is everything that is expense. So that is why each individual tool is a very thin layer. You have to keep your tools to be a very thin layer, and you have to reuse your existing service. That's what I'm trying to say. You can have such tool factories, multiple tool factories, a set of tool factories. Here I have made a two separation group, but rather than having like that, let's say one which mutates the database state can be a one tool set, just a random example, and which is just a get query operations or something of that sort, can be another factory. You can instantiate, you can use the factory pattern and then play around with it. And you have to have a strict schema validation. Guardrails is something which we're gonna touch across in detail in coming point in time. But yeah, this is how the stuff that goes on during the tool centric design and an interface layer, right? Inference layer. Now what else? So if I have to tool centric design is something which, where you covered the business logic out of the prompt, which I tried explaining that. So you see that if you look at my prompt, right, if for this entire expense stuff, if you just look at this, you see this, there is only one line of code, that too not little long. Already I'm getting into today's date, right? So that's all. Everything that which I want to say will be told by whom? Will be told by my service and by tools. If you get to this, tools provides a neat way of saying at runtime it dispatches this description to the LLM. This is something which will be read by LLM. right? So that is what tools, having a thin layer of tools and very descriptive tools like this gives help. Even for you would be able to, tomorrow you are doing a maintenance job, at that time you will be able to, what is this tool that I am trying to say, if you read the description it will be very handy for you. And likewise how the LLM also try to dispose this tool while it is acting it out from the graph. So yeah, I think so your agent follows same hardened, unit tested, validated logic similar to your existing REST API. Yeah, that is something which we covered, right? So entire thing that was there as an API service layer will be used by your graph now, just that you have a tool layer on top of it. That is where the magic happens, having a thin layer of tools. Again, I've covered sufficient. Let's get into another one. That is, yeah, we will quickly see the real-time transport SSE layer. So in the SSE layer comes in this chat controller. It can be an altogether another layer as well, but in this chat layer, make sure that you are using these two important event stream and keep alive, because it is a live connection. There will be a time to live for this, and make sure your front end is catering to this timeout condition. So since you are using an SSE, the client shouldn't feel that no more the backend server is sending the signal to me, so that I have to end this. I have to treat that this is. So if you use Next.js or any other matured framework, you can make use of having a extended, if at all if it is an SSE, it will understand directly, the handshake will understand that okay, this is an SSE connection, I have to keep live this connection. So there will be intrinsically, so but make sure that if you are ever subscribing to an SSE, there are these two little headers, and you have to immediately send. Here in this case I am not sending, but you have to immediately send an accepted message to your front end, so that it starts, there is an immediate, because LLM, see, think about this in this way, LLM takes good amount, if you are using a reasoning model, right, LLM will take enough amount of time to think over whatever the task that you have assigned to it. The bigger the task, bigger the thought process is, right? Till then it will not generate a single value of text, or it will not even act out on the tools. Till that point in time, your loader keeps on spinning. If you are using a chart interface, or if you are using a blunt interface like a command console or something like that, so there won't be an immediate handshake. So if you are using SSE or within your MCP, make sure that for any long running process, there is an immediate acknowledgement, okay, the message has been received and LLM is at work. That is something which you give as a quick handshake back. That is one stuff that you need to keep note of. Next is second stuff. The second stuff which I'm saying here is having an agent state transitions. That is, okay, SSE is used for, obviously I need not cover this. What is SSE is used for? SSE is used for all your thought propagation, your LLM's thought propagation, your custom state propagation. What is custom state propagation? If you see this, there is a custom state, and this custom states gets generated within my graph. If I ever have to send a custom state, right? So if you see here, see this custom message, this custom message gets connected here. If I am making a call and I say to that call that it is a tool called start, and some of the, even in I think Agentic software development kit or something, there it was built in. But if at all, if you have to use it on your own, if you have to write an event streaming on your own, you make use of a custom stream delegates like this, and you construct your own messages, give that the event is tool called start, and this is what the payload that it accepts, so that your front end or whoever is consuming that, you are trying to make a tool call that they can branch out of it. What is a simple branch may look like? It might look as a simple GUI, where a simple UI says that so and so tool is being utilized while I make this work for you. Or it can be as simple as I'm thinking on these many thoughts. So it can be as, for thought process also, you can say that thought start kind of an event. And in all this, what comes handy are these, what we call it as a discriminated unions, right? In the stream message, if you see, these are the discriminated unions. So what are these? These are particularly to TypeScript. These are type safety measures. These are the types that I will use, if at all, if this is like a contract between your consumer and your backend. Your consumer might be a front end API call. That consumer, your front end chat layer is dependent upon this is how the structure of your tool called start payload will look like. This is something which is shared. You can keep it in a shared common repo. If client and server sits here, it can stay in a common folder here called as shared. But I have duplicated this because in client side I have even a number of other types, discriminated unions that I wanted to use. That's why I have copy pasted and I have made it kind of an enhanced model. If you look at my client side, if I go to app, I think config use cases, sorry types, I have kept it right here. So if you look at this, these are server side types, which these three will bare minimum be copied into the types of this. Along with it, I have added something of other things as well, like user, and you can extend on that feature. So what does this type say to my client or a consumer? See, this is what the agreed upon event will look like, and this is what the payload will look like, and their data structures will be in this way, their data types will be in this way. So it is very important whenever you work with SSE layer, it is very important you communicate this contract to your consumers. Otherwise they would not know what to be expecting on what particular event. So server sent event is all about event, right? A server is trying to create up an event and send it to you, trying to communicate not just through its end result but through its intermittent results as well. That is the whole idea of a real-time transport layer, which is an SSE. So having an SSE in your agentic landscape is must, because it is very verbose, it is talkative. Your LLM itself is a talkative thing. So yeah, and one more thing is that stream resumption, if you go to the chat control layer, you can even delegate out this ID, the last event ID, to your external database, and then resume it back. What does this give? It's kind of a resume. So what do I mean by this? Let's say you have again coming back to always LLM takes a long time to have a reasoning of thoughts, and in between that there is an intermittent failure of network or something of that type. What should have is this last event ID need to be pushed into either your in-memory data structure or to an external data structure, so that if it comes ever back, you can resume this. Think about this in this way. I mean, I don't know whether this application, this particular model applies to your Gemini model or not. I'm thinking I'm thinking out loud. Let me know in the comments as well. But in any case, in Gemini, you see that there will be a nice little side panel, where in that side panel, if you go to your chart history, if you have subscribed to saving up your chart history with Gemini, you can go back to your 10th days. I mean, today is today, and then there is yesterday is yesterday, and then there was 10th day. Sorry. I mean, just go back 10 days before, and then you click on that 10th day chart, right? You get back whatever the resumption, that whatever the chart model that was there. How is that happening? And you can resume back. If you say what is the context that I am here in this particular chart, it resumes back. How is that happening? Due to this resumption, if at all that resumption, I don't think so that resumption has to do with this, but in any case, if it can be used, we can use it. That is more of to do with context engineering, the next very little concept that we're gonna discuss about. But yeah, utilize the thread IT to reconnect and rehydrate the state of checkpointers without rerunning the previous states. Yeah, that is something which we're gonna discuss and then figure out. But yeah, having a real-time transport SSE layer is what we need to concentrate upon, and then there should be a last event ID. If at all there are interim network connection failures, you can always resume this back, right? That is what SSE is all about. Next, let's go to context engineering. So you see this: manage a long-running threads by condensing historical context into a persistent state summary to prevent token overflow and context drift. This is something which is a big jargon. Context engineering, all it says is very simple: leave out the engineering part. At any point in time, the context is not only your prompt, right? How many times will you send this prompt? You need to have this prompt at every single chat that which you're gonna have with it. But is that all? When your chat history grows and grows, at that time it need to profile you out. It need to say, if at all, if you are doing a personalization chatbot or something like that, it need to profile you up. What are the preferences of this user? If you are doing a coding agent, what are the, whether the user likes a dark theme or not, or something of that sort, it need to profile you out. It need not be only profiling, right? You might have an entire context which is a very big in nature. How much of a context does a LLM can have? Today's Gemini can have a, I think so, if you check the context window for Gemini, right, it is very big, 2 million tokens, roughly 1.5 million words, that is 30k plus lines. Even then it is a shortfall, it is a finite number, right? So how do you engineer this? I mean, use a typical sliding window strategy. Whatever that is required, you keep that. Whatever the, or otherwise you summarize and then keep it. That is what this entire thing talks about. Let's quickly go through this. Conditional summarization trigger. Implement a logic gate that routes a summarize history node once to state message length exceeds the threshold 15 messages. So it is saying in your lang graph where it is your expense agent, have one more node called as what? Called as a dumb node. Let it be, as of now, to figure it out, let it be a dumb node. So in this dumb node, if the entire state.message.length is equal to more than 15, let's say, if it is, it need to be a configurable number. You can keep it in a configuration in your app side configuration. At runtime you can mix and match what is the context engineering that you want. That's the power, right? So let's say right now the agreed upon number is 15 messages. I will be within context. So if it goes, as soon as it goes out of that 15, let's say 16th message arrives in, what you do is you redirect from that node to an LLM node. That LLM node need to be what? That LLM need to be a super node, a kind of a model which is good at reasoning. Don't use the same production node that is generating a text and acknowledging the user prompts and all that. Use one more node which is very apt in reasoning. If you head to Grok cloud, right, they give you the reasoning models as well. So make sure that you are subscribed to a reasoning model, because now you will be trying to summarize all that 15 messages that flowed into a one big set of context. That context is something which you gonna preserve, and that preserved context now can be utilized during the runtime. Instead of having a 16th, 17th or a 25th long messages that each time that it need to go through this, instead of doing that, you have a summarization message. That is what it has. See, at the end of it, the system message is this existing your message and your recent messages. System prompt can be your system prompt, your existing summary which you did just now, and your recent messages. So it need not, it can just have a gist of what has been discussed so far and what is that presently the user is trying to probe upon. So that is how the dynamic system prompting works. And you can always have a state pruning if some of the messages are irrelevant. If something have been said as hi, hello, how are you? I mean, always the beginning of conversation happens in this way if it is a chatbot, right? So you can just, why do you want to preserve that state in state.messages? All of that, greeting, salutations, or something which was a quick information to, by the way, what was the time today? Was it relevant? No, something which is irrelevant, you can strip it off. So you can have a prune node. You can have a compression node, as I told you before, right? So you can have this, each one of these can be a node. You can have a summarization trigger node, which is a dumb node which doesn't require an LLM, it is just a programmatical node. You can have, then it can be led into a compression node where a higher model compresses that entire 15 messages or whatever the agreed upon messages into a one good of a summary, and that summary can be used for dynamic system prompting. And at the very end, whatever the salutation and greetings or whatever that were there, that can be pruned off. That's the overall simplistic state window and summarization. We can talk about context engineering in general. We can talk about much about details, but this is something which you would start upon. Otherwise, your context will be blown out of context, and your tokens will be done what? Your token cost will increase n number of times, and then you would have a high paying model with you. Your AI agent workflow would then be will be very will not be very very apt. Rather, it will be hallucinating here and there, since it has a bigger context window. A number of stuffs can happen, which you might have guessed it correctly, right? So yeah, till here, what is that we have discussed? We have discussed that this entire stuff, if you just go if you go one of my model, I've written one little summary over there. That summary is, building an agent is 20% of the work. The other 80% is about infrastructure that makes it reliable, observable, and fast. In one such reliable fashion is what we are trying to construct here. What we are trying to do by backend engineering is that we are trying to make this entire LLM flow as reliable as possible, right? So then in the next upcoming video, we'll see how to increase the reliability and observability through TDD and LLM as judge evolves and structured tool traceability. Exactly, once you have built upon in these fashion, that is when, if you use these kinds of tool, it will give you a validated summary of, okay, now your indeterministic LLM agents or your agentic AI stack is determined. You can measure, you can gauge, you can see at what particular state it behaves in what fashion. Think about it. In previous to API models, you always knew what's the input that you sent and what output that you got. But even with case of agentic, you cannot always say that this is how the format will be. But by using these methodologies, you can still have an LLM node in between your work and see whether it works or not. It produces a deterministic state or not. So that is all about the context engineering, the the real-time transport layer, the tool-centric design and inference layer, your agentic graph, and dependency injection, where it all kicked off. So these are, I have missed a multi-layered guardrails. If I have to quickly go about this multi-layered guardrails, right? Think about this in this way. This is very optional. If you have a service layer which is taking care of your error handling, your business scenarios, that guardrail need to protect your LLM not from being hallucinated or being grounded or not violating your business construct. In my expense agentic flow, what I have implemented is this little service. If you see this expense service, it makes you something of a select query guard. What is this select query guard? This is a multi-layered guardrail which I have introduced. To some extent, I made it I made it a typical guard. So where have I put it? I put it in utils, I think so. Let me know whether it is a correct place to be at or not. All that it will do is, so I have given a free flow of a free complete my LLM can run read operations, right? So while imagine now what I have done here is I have given a read only operations token to my LLM, and also I have given not to my particularly LLM, to my set of tools, and my service layer gets accessed and gets injected during runtime. That is what we discussed in dependency injection. That's what I mean by my LLM can run free on my database. It can go wild. So do it really need to go wild in order to just to select certain tables and do an inference on the basis of it? So who keeps that in check? This SQL guard, this validator for each query that it generates while it consumes a tool called as, if you see this tool, you see this tool that get expense. In this get expense tool, I made my LLM itself to generate a query for me. You see this? The input to this tool is query, and who is generating this query? Whoever is the user of this tool. And who uses this tool? The LLM uses this tool. If you see this input, strict SQL query, optimized query for efficient data retrieval. Now this query can also be wrong. It can also generate a disastrous query like insert, update. Somebody can inject or trip and trick your LLMs in order to generate all this, something which is forbidden. So I have kept this forbidden keyword. I have made this into a impregnable model, as of at least taken some effort into it, we can always have a bug raised upon it, a security vulnerability scan raised upon it, and we can extend it. So the overall idea revolves that you have taken care, and then there is one class or a particular thing that is taking care of it, and it is just up to the maintainers of it that they can keep on adding or keep on updating. At least you have taken an onus of writing at least the inception model of this is what the overall idea of this entire production grade AI agentic system is. This is in short what a multi-layered guardrails is. So yeah, this have to cover everything that has been written in this, and I will be keep on updating this as and I figure out. But this overall area, right, having an IoC, cyclic DAG, a tool-centric, a lightweight tool-centric design, a multi-layered guard, and context summarization will help you to script your backend AI agentic system like you did before. 50 to 60% remains same, and 40% there are particular nuances which we just talked about when it comes to AI agent. If you understand these nuances, have this baked in your head first, and then have a chat with your Gemini or your coding agent. See, this is what I want to get implemented, right? At that time, you make your AI agentic more scalable, more not scalable, at least a stateful distributed system, a production ready, a testable, a maintainable, injectable services, right? That is what then that's what the overall gist is. You can, I will link this gist into the into the description tab, and also give you the reference of this. But you can always grow out of this. I recommend you to grow out of this. So the overall thing is, if I have to in short summarize, your roots are there, and then what was there was okay, this is not scrolling, so yeah, yep, you see this. So the roots were there, and then you were eating what? You were eating your controllers. Till here it was same. And what more is that this injected agent, your lang graph state, right, your tools, and in turn your services and your data. So these injected agent, your lang graph state, and tools together, this can be a two little simple tier that got added. So there were 3 tiers to begin with. Now it became an n tier. You can make it to an n tier, but as of now I have talked you about 5 layers of it. You see this layer 1, layer 2, layer 3, layer 4, and this is your layer 5, which is taken care by Drizzle in this case. So these are the 2 little loads that got added. That's the end of it. If you like this, go ahead and bookmark this by making this just a star, so that you next time you have a basic model to begin with. That's all. Going forward, we'll see how to make it more reliable by making it a red to green TDD, and see how we can write LLM as judge evals and whatnot, right? So that's it for this video. Thanks for sticking so long. Hope this was informative to you. Thank you. It was indeed for me. Thank you.